The first humanoid statically and later dynamically balanced robot, WABOT, by Ichiro Kato of Waseda University, Japan, was developed around the same time. For such achievements, these scientists must be recognized as pioneers of humanoid robotics. Since then, many scientists and engineers have been working on this topic. In 1997, Honda Motor revealed the humanoid P2 at the 1997 IE International Conference on Intelligent Robots and Systems, IROS, in Grenoble, France. Subsequent development led to the Asimo robot announced in 2000. The impact was felt beyond the robotics community. The general public was excited by its human-like android shape, natural gait walk, automatic slope balance, ability to climb up and down stairways, and human interactions. An increasing number of researchers have since been challenged to further develop humanoid robots. Humanoid robots can represent a research platform for studying not only robotics, but also human beings. This is especially true for neuroscience, where human brain models can be implemented on humanoid robots. This can allow testing and validation of these models in addition to providing humanoids with human-like sensoromotor functions. In fact, Mitsuo Kawato of ATR Japan proposed using humanoid robots to study human behavior at the beginning of this century. 3. In Europe, this approach has been pursued in a number of EU-funded projects, which include the large-scale Neurobotics project, 4, across neuroscience and robotics, and the Robot Cub project, which led to the Open iCub platform for the study of the development of cognitive capabilities. 5. Today, the Human Brain Project consists of a dedicated neurorobotics platform for the implementation of brain models. Humanoids represent one of the ultimate goals of robotics, to synthesize advances from many disciplines. These robots are inherently cross-disciplinary, involving advanced locomotion and manipulation, biomechanics, artificial intelligence, machine vision, perception, learning and cognitive development, as well as behavioral studies. For this special issue of humanoid robotics, we received a wide variety of papers in the field of the biomimetic design, stability and autonomous control, adaptive walking to rough terrain and natural gating, robust control for avoiding falling on the ground, adaptive behavior, robot machine learning capability, real-time visual recognition and understanding, multi-robot cooperation, human-robot coordination, human psychological aspects, and many others. Some of them are included here, and others may appear in future issues of Science Robotics after further revisions. The editors are grateful for all contributions submitted to this special issue, and we hope that this field will continue to grow and prosper in both research and development, targeting real-world applications as expected by the general public rather than restricted laboratory settings. Imagine a world where the line between science fiction and reality blurs, where humanoid robots are no longer confined to the pages of dystopian novels or the silver screen. Instead, they're walking among us, dancing in nightclubs, and, yes, gearing up for war. This isn't a far-off future. It's happening right now. The debut of the Phantom Mk1, a humanoid war machine, at a San Francisco nightclub has sent shockwaves through the tech and defense industries. But this is just the beginning. From AI research agents that can replace hours of human labor in minutes to humanoid robots designed for both industrial and military applications, the robotics revolution is here, and it's moving faster than anyone could have predicted. Let's dive into the wild world of humanoid robotics, where the stakes are high, the technology is groundbreaking, and the implications are nothing short of mind-blowing. The Phantom Mk1, a war machine in disguise. Picture this. A sleek humanoid robot takes the stage at a San Francisco nightclub, moving to the beat of the music. The crowd is mesmerized. But this isn't just a high-tech party trick. This is the Phantom Mk1, a humanoid robot built by Foundation Robotics Labs, a startup headquartered in Frisco. The company chose an unconventional venue, the Temple nightclub, to unveil their creation during the quarter-of-the-century tech Giga Party. While the robot's dance moves and music selection were pre-programmed, the message was clear. This is no ordinary robot. Founded in 2024 with $1 million in seed funding, Foundation Robotics Labs is the brainchild of Sanjay Pathak, a former fintech entrepreneur whose previous venture, Synapse, a banking-as-a-service platform, went bankrupt. Pathak's pivot to robotics was fueled by a vision of creating humanoid robots capable of handling everything from manufacturing tasks to military operations. His co-founder, Mike LeBlanc, a former U.S. Marine and co-founder of security robotics company Cobalt AI, brings a wealth of experience in defense applications. Together, they're pushing the boundaries of what humanoid robots can do, and they're not shy about their ambitions. Pathak has been vocal about the need for the U.S. to keep pace with China's advancements in defense robotics. In his words, advanced humanoids could be essential in future warfare. The Phantom Mk1 is a testament to that vision. Standing at 1.75 meters, 5 feet 9 inches, and weighing 80 kilograms, 175 pounds, this robot is designed to handle a 20-kilogram, 44 pounds payload. Its advanced cycloid actuators combine the power of hydraulics with the efficiency and quiet operation of electric motors, delivering a peak torque of 160 Newton-meters, while maintaining precision with a backdriving torque of under a single Newton-meter. The Phantom Mk1's upper torso houses its central command system, including batteries, processors, cameras, and sensors for 360-degree situational awareness. Its lower torso is engineered for balance and mobility, allowing it to navigate uneven terrain, climb stairs, and operate in confined spaces. With a human-like gait, the Mk1 is designed to work in environments originally built for people: factories, offices, disaster zones, and yes, battlefields. Foundation Robotics Labs has ambitious plans for the Phantom Mk1. They aim to ship over 40 robots in 2025, scaling up to 10,000 in 2026 and more than 20,000 in 2027. Their target? $1 billion in annual recurring revenue. But their vision doesn't stop there. The company dreams of using their profits to establish a base in Antarctica and eventually expand to the Moon, Mars, and beyond. It's a bold vision, but one that reflects the growing trend of tech companies embracing defense applications. The defense angle, a growing trend. The Phantom Mk. One isn't the first humanoid robot with military potential. In 2011, Boston Dynamics, in collaboration with DARPA, developed Petman, a humanoid robot designed to test chemical protective suits for the U.S. Army. Later, they introduced Atlas, originally funded by DARPA for disaster response, but later pivoted to industrial applications under Hyundai's ownership. Russia also made headlines in 2016 with Fedor, a humanoid robot allegedly designed for space missions, but capable of carrying firearms. What's different now is the scale and speed of development. Companies like Foundation Robotics Labs are pushing the envelope, and they're not alone. Tech giants like Meta, OpenAI, and Google have started reversing their anti-military stances, opening the door to defense contracts. This shift reflects a broader trend: the convergence of cutting-edge robotics and AI with defense applications. Bridging the gap. From simulation to reality. While Foundation Robotics Labs is making waves with the Phantom Mk1, researchers at Carnegie Mellon University and NVIDIA are tackling one of the biggest challenges in robotics: bridging the gap between simulation and reality. Their collaboration has resulted in a framework called ASAP, aligning simulation and real physics, which allows robots to train in virtual environments before transitioning to the real world. ASAP reduces motion errors by 53% compared to older methods, enabling robots to perform complex tasks like forward jumps of more than a meter. However, the team faced hardware limitations during testing, with some motors overheating and damaging 2 test units. Despite these setbacks, the researchers remain optimistic, viewing every shortcoming as an opportunity for improvement. They've also made their code open source on GitHub, encouraging collaboration and innovation within the robotics community. The rise of dexterous humanoids. Meet Atom. Another player in the humanoid robotics space is PND Robotics, the company behind Atom, a humanoid robot designed for precision tasks. Atom's dexterity is on full display as it performs calligraphy and other delicate maneuvers requiring fine motor control. With 37 degrees of freedom and 20 actuators, Atom is a marvel of engineering, capable of assembling tools and balancing objects with ease. PND Robotics has also introduced an imitation learning framework, allowing Atom to learn locomotion by analyzing human movement data. The result is more natural, agile motion, a far cry from the rigid mechanical steps of older humanoids. The future, a world of humanoid robots. The robotics world is on fire with breakthroughs. Foundation Robotics Labs aims to solve labor shortages and push into defense, envisioning a future where humanoid robots like the Phantom Mk1 handle everything from manufacturing to warfare. Meanwhile, researchers at Carnegie Mellon and NVIDIA are bridging the gap between simulation and reality, enabling robots to replicate virtual skills in real-world environments. And with companies like PND Robotics showcasing the dexterity of robots like Atom, the possibilities are endless. In an era characterized by rapid technological advancements, humanoid robots and embodied artificial intelligence, AI, stand out as frontiers pushing the boundaries of what machines can achieve. Humanoid robots, intelligent embodiments designed to resemble and mimic human behavior, have the potential to revolutionize various areas, from healthcare to industry and beyond. Equipped with advanced sensors, actuators, and AI algorithms, these robots can perform tasks with precision and efficiency, freeing humans from mundane or dangerous activities, offering personalized assistance to individuals with disabilities, and providing companionship and aiding in therapy sessions. In a broad context, they cut across many disciplines such as mechanical engineering, control engineering, AI, and cognitive science. These technologies, which merge the digital intellect of AI with physical embodiments, are not just the products of scientific endeavor, but are also becoming integral to addressing complex societal challenges and keys to the potential future they promise. But with these advancements come questions. What does the future hold for humanoid robots? Will they become indispensable tools in our daily lives, or will they pave the way for a dystopian future where machines dominate? One thing is certain. The robotics revolution is here, and it's moving faster than ever. Conclusion: a brave new world. The debut of the Phantom, Mk1 at a San Francisco nightclub, may have seemed like a spectacle, but it was a glimpse into a future where humanoid robots are no longer confined to labs or battlefields. They're here, and they're evolving at an unprecedented pace. Whether you see this as the next logical step in technological evolution or a path to potential dystopia, one thing is clear: the age of humanoid robots is upon us. Thanks for joining me on this deep dive into the world of humanoid robotics and AI. If you enjoyed this exploration, hit that like button and subscribe for more updates on next-gen robots and AI breakthroughs. We've only scratched the surface. And stay tuned, because the future is just getting started.